Today we're going to continue with multiplying polynomials, and we're going to look at multiplying a binomial times a binomial. Right? A binomial has two terms, so we have something with two terms times something else with two terms. Okay, notice there's no addition or subtraction sign in between the parentheses telling us that this is multiplication. So our first step when we are multiplying two binomials is that we are going to distribute the first term to the second binomial. Right, so this is where that vocab is important, right? Knowing that the first term is our first term right here of 3x, and we're going to distribute that to our second binomial, which is this whole entire binomial over here. All right, so I'm going to take 3x times 2x. Maybe zoom in here just a little bit more. Right, 3x times 2x minus 4. And that's something we already looked at yesterday. So we're taking 3x times 2x, which gives us a 6x squared, and 3x times a negative 4, which gives us a negative 12x. Okay, our second step is that we are going to distribute again, but now we are going to distribute the second term to the second binomial. Or I'm going to take this 7, I'm taking that whole entire sign with it because it tells me it's positive, a positive 7 times a 2x minus 4. Right? I don't really need that addition sign there. It tells me that it's positive, but just reminding me that it's positive. So that's going to be a positive 14x and a negative 28. Our third step is that we're going to need to combine any like terms. So I need to recognize that this is an x and this is also an x, right? Those are both x to the first power. We can add or subtract anything that has the same label. So those both have an x to the first power, right? So my 6x squared doesn't have anything it can go with, but a negative 12x and a positive 14x give me a positive 2x, and that negative 28 just comes along. So there are multiple ways that we can write and do this process when we are multiplying binomials. So I'm going to go through the next couple problems and show you a few different visual options that you can use. Option 1 is to really show how we did up here and to separate this. So to take this first binomial and sort of think about it as two separate pieces. The first term is x, the second term is positive 6, and we're going to distribute both of those to the x plus 2. So I'm going to take x times x, which gives me x squared, and I'm going to take x times 2, which gives me a positive 2x. Now, one of the visual cues that my students really like is on this next piece, when we take 6 times x, 6x is a like term as 2x, so I'm going to write that positive 6x underneath the 2x because they're like terms. Okay, and then 6 times 2 is 12. 12 is a constant. That's not a like term with anything else, so it's going to get its own row. And that way, when I go to combining like terms, I can just do straight down like that stacked addition we looked at previously. So this will give me an x squared plus an 8x plus a 12, and that is my simplified answer. Okay, another option is to just think the distributing. Lots of my students like to actually draw the line in. So when they look at this problem, they say, okay, I'm going to take 3c times 2c, which gives me a 6c squared. I take 3c times negative 11, which gives me a negative 33c. Okay, and then they think about distributing the second term. Now we're watching our sign carefully, right? We're going to distribute a negative 7. So negative 7 times 2c is a negative 14c. Now I'm still doing that visual cue of stacking if it's a like term. Negative 7 times a negative 11 is a positive 77. Right? And then again, I'm going to combine like terms. I still have that nice visual stack look of a 6c squared minus 47c plus 77. Our third option is that you don't stack them at all and that you just choose to write them horizontally, right? So you can say 4u times 3u is a 12u squared. 4u times -5 is a -20u. A positive 9 times a 3u is a positive 27u. And a 9 times a -5 is a -45. Right? I'm just writing all the pieces horizontally. Okay, then do the same thing. Decide if there are any like terms, just like we did with adding and subtracting when it was written horizontal, right? We find some and we put them together, making sure that our final answer is in standard form. So I would really suggest that you take a moment and you pause this video and you do example E on your own. And then when you're finished, press play again to check and see if you got it correct. Okay, so if we look at this, we should have done a W times a 3W plus 8 and a -4 times a 3W plus 8 for a 3W squared plus 8W minus a 12W minus a 32. And that's a 3W squared minus 4W minus 32. If we look at example D, in example D, notice we have varying exponents happening here. We are allowed for any situation of any type of binomial to happen. So if we look at example D, we're going to follow the same process, but our numbers might be different. So if we distribute here, right, a 7y to the third times a 4y squared is going to give us a 28y to the fifth, right? When we multiply, we add. 7y to the third times 7 is going to give us plus a 49y to the third. And when we distribute our next one, a -10 times the 4y squared will be a -40y squared. Now, I'm writing this over here because none of these are like terms, so there's nothing to stack. And a -10 times the 7 is a -70, right? And in this situation, there's nothing to combine. That's our final answer. We also can multiply binomials when there's more than one variable. So if we look at example F, again, we're going to do the same process. However you choose to write again is fine. I'm just picking some various ones as we go through. So 2x times 7x will give us a 14x squared. 2x times a -6y will give us a -12xy. Remember, right? It doesn't matter that those don't match when we're multiplying. They just become part of the final answer. Then I'll take a -5y times a 7x, which will give me a -35xy. Now, this often confuses students, but right, these both have an x and a y, so these are like terms. Those labels are exactly the same, so they can be combined. And a -5y times a -6y will give me a positive 30y squared, right? A negative times a negative is a positive. So when I combine like terms, this will be my final answer.